All right, the next thing we're going to do with radicals is we're going to rationalize the denominator. One of the three things, you cannot have a radical in the denominator of a fraction. So this is the process called rationalize the denominator. And when you look at this problem, all the other rules hold true for simplifying. So if you look at this example, the first thing I would recommend doing is simplifying the problem. So I would have square root of 4, which is 2. Okay, on the bottom, I can rewrite this as 2 square root of 4 square root of 5 because the square root of 4 is a perfect square and it's a factor of 20. So it'd be 2 over 2 times 2 square root of 5, which is 2 over 4 square root of 5. Now, the reason this problem is no good the way that it's written is because this 5 is underneath the radical in the denominator. I am not allowed to have a radical in the denominator. So to get rid of that, I do what's called rationalize the denominator. I'm going to multiply both top and bottom by that radical. Okay, so I would get 2 square root of 5 all over again. You can't multiply these two because this is outside and this is inside. And then I would have 4 times the square root of 5 times the square root of 5 is the square root of 25, which is just 5. So this would be 2 square root of 5 all over 20. And then I can reduce those two. The 2 over 20 reduces to 1. I can put a 1 here, but I'm not going to. Square root of 5 over 10. So this would be the reduced form of this radical. Now, I also could have, and for some of you that aren't great with simplifying right off the bat, I could have written this as 2 times 2 square root of 20, and I could have multiplied top and bottom by square root of 20. So on the top, I would get 2 square root of 20 all over 2 times square root of 20 times the square root of 20 is just 20. All you do is write the number once and the radical disappears. The reason I don't like this is because this now has to simplify in the numerator. This could be written as 2 square root of 4 square root of 5 all over 40, which is 2 times 2 square root of 5 all over 40, which is 4 square root of 5 over 40. And then now I have to reduce that. It just ends up with larger numbers, and it gives you the same answer. So you can do it either way. I just encourage you to simplify first. If you simplify first, then most of the time you'll get easier simplifying. Okay, so let's take a look at this problem. 6 over radical 10. Again, the reason this is not simplified is because there's a radical in the denominator, and 10 can't be reduced. There's no perfect square factor. I know 2 times 5 is 2 factors of 10, but they don't multiply. Neither one of those is a perfect square factor. So I'm going to multiply the top. Now, again, stressing, I can't multiply the 6 and the 10. I know I can. It's 60, but because this is outside and this is inside, you simply just rewrite it 6 square root of 10. And then the key to rationalizing is knowing that when I multiply the square root of 10 times the square root of 10, it would give me the square root of 100, which just simplifies to 10. I think this point right here is a little bit of extra work. Anytime you multiply two numbers that are both underneath the radical that are the same, it's going to equal that number. And then now I look at the two numbers that are on the outside. Can I simplify those? Yes, they're both even. So it'd be 3 square root of 10 all over 5, and that would be the simplified answer. Okay, let's do one more of these. Expression simplest form. So again, I would highly recommend that you simplify this. This can be written as 2 square root of 4 times the square root of 7, right? Which is 2 over 2 square root of 7. And if you wanted, you could simplify this right now, seeing that those cancel. I'm not going to. What am I going to do to rationalize the denominator? I'm going to multiply top and bottom by whatever's underneath the radical. So I would get 2 square root of 7 all over 2 times square root of 7 times square root of 7 is 7. So I have 2 square root of 7 over 14. And these two are going to reduce. On the top, it's going to leave me with 1 square root of 7 over 2. So that would be the simplified form of that.